Oh.
Okay, you can. Fine.
All right. So, welcome to the 2100 slot. It's public transportation, the SMS ticket hacking from Pavel. So, please give me your hands.
Okay, so welcome at my presentation. My name is Pavel Lupták. I'm from Slovakia. I work as a security consultant in one penetration testing company. I appreciate if this talk would be more informal. So if you don't understand anything, or just raise your hand and ask me, and I will explain you. No problem. Okay, so I'll be talking about public transport SMS tickets hacking. SMS tickets are massively used in Central Europe, mainly in Prague, Vienna, Bratislava, but also in some other cities. How it works? When you want to buy SMS ticket, you just send some special request to some specific number. For example, TBT, and in a few seconds you will receive unique SMS response, which is supposed to be your unique SMS valid ticket. It means that for example, this is example of such SMS ticket. This is unique code, which is valid from 1 p.m. 20 to 2 p.m. 50. And when you meet a public transport inspector, you just show this SMS ticket to him, and he can verify it by just writing down this SMS ticket to his PDA and verify if your SMS ticket or SMS public transport ticket is valid or not. Many public transport companies have possibility to request for a duplicate if the SMS ticket is deleted, or you lose your mobile phone, or your mobile phone is out of battery. Okay, so firstly, who is still vulnerable? Biggest public transport companies in Czech Republic, Slovakia, Poland, and also Austria. I don't know what is the situation in other countries, but some people told me that SMS tickets are also used in Holland. So. I contacted these public transport companies approximately 1 year ago and sent them this paper. I explained it to them how serious is this vulnerability, but they still ignore this fact and still use the vulnerable systems. So at this moment, I have no information if there are some public transport company who use safe SMS public transport ticket. Okay, so how it normally works? So you want to ask for SMS ticket. You just send text message with some text, for example, DPT. This text message is received by public transport SMS ticket server. Public transport SMS ticket server in a few seconds generate for you unique SMS tickets, and this unique SMS ticket is sent back to you in a few seconds. Okay, so there is some all valid SMS tickets database. Okay, so let's go to look for some security problems. SMS token seems to be quite random, and it's very difficult to predict, as you can see. The other problem is that the inspector uses his PDA for online verification. So his PDA uses some GSM module, and when you meet this inspector, he just writes down your SMS token, and in a few seconds he finds if your SMS ticket is valid or not. But there's a big security problem. There is no connection between user identity and his SMS ticket. it means that this SMS ticket can be for defined period shared by community, by some hackers community. Legislatively, it is prohibited to generate these SMS tickets, these copies of SMS ticket, but practically, at this moment, there is no way how to detect these duplicates. So when you decide to follow this paper, this presentation, and make your own implementation, there is no way how to detect it, or how to detect it quite cheaply. Yet?
Excuse me, why is it not possible to detect if a ticket is duplicated? Because the inspector uses PDA for an online verification, and it should be a way to close the ticket that was shown for the first time or so.
It's not possible because this SMS ticket is not associated to the name of to this person. This SMS ticket is associated only to his mobile number. But this week, so in the following minutes, I will explain and I will show you how it is possible to make full man-in-the-middle attack, full man-in-the-middle attack between passenger and public transport inspector. So you will see. Be patient. Okay, so we need to do two things. First, we need to find a way how to effectively generate SMS tickets. I found out that any SMS message can be easily locally generated, but you need a special smartphone. Every mobile phone with Symbian, Windows Mobile, or iPhone has a capability to generate local SMS with predefined sender recipient body and also status flag. It means, for example, we are able to generate visually absolutely same SMS, including not read yet flag. So we practically verified this behavior. We were able to generate local SMS on Symbian S60v3. Now we need to solve SMS distribution. So we need to solve. We need to find a way how to distribute original SMS ticket to members of hackers community. There are two ways. The first one is using SMS channel, which is quite expensive, and in this method we can't modify SMS headers. For example, send the recipient status flag. But there is another better way using TCP/IP, which is very cheap because we send just very short SMS requests and SMS responses. But the problem is that you need to have some prepaid mobile data service. You need to have access to internet through your mobile phone. And of course, your mobile phone has to be capable to generate local SMS. So you need to have smartphone, of course. Okay, so this picture of our hacked SMS ticket architecture. As you can see, in every mobile phone, there is special SMS hack client installed, which is Java, not only Java, but mainly Java application. This application communicates using TCP/IP with SMS hack server. All communication is encapsulated in SSL, secure socket layer, so it's point-to-point fully encrypted. Then we have a mobile phone, which is connected to central SMS hack server, and we use this we use this mobile phone for sending original SMS request to public transport company and receiving original responses and then we distribute these SMS responses or valid SMS tickets to all members of community. So SMS hack server is responsible for communication with connected mobile phone. This is done using 80 commands, and we can use many libraries. I will show you on another slide. Okay, so SMS hack server is responsible for sending original SMS requests to public transport company. It also communicates with a connected mobile phone over USB, serial, Bluetooth line, it doesn't matter. And use some high-level library like libgam or libgnocchi. SMS hack server is quite simple application. It's just only one-thread application that listens on some TCP ports and handles multiple SMS clients. It also parses and receive original SMS tickets from public transport company. What is really important in the SMS ticket is unique token and ticket's validity, so start time and expiration time. Also, SMS hack server holds information about clients. It means if the given SMS ticket expired for given client, information about this client is removed from this central SMS hack server. Okay, SMS hack client. SMS hack client always creates a connection to SMS hack server. So it passes through multiple NATs and firewalls and send various specific commands like get token request, regenerate token request. If you have enough time, I can explain exactly how it works. And also, SMS hack client receive from SMS hack server information about valid SMS ticket, and locally he completely generate a valid SMS ticket with valid unique token, with valid sender, with valid recipient. Okay, so user interface of hack client is very easy, so it can be used by anyone, including my grandmother. So there are only 4 buttons. Get SMS ticket, you push this button when you want to ask for valid SMS ticket. Regenerate SMS ticket function, which is used when you meet some public transport inspector. So he checks your ticket, and if there is some restriction that this ticket cannot be used 2 times, you need to push this button, regenerate SMS ticket, and all members of community in a few seconds will receive new valid SMS token and some other option, get SMS status, set options. Okay, so at this moment there are many ways that are inefficient how to detect this described attack. All of these methods or all of these ways from public transport company can be circumvented. I will explain it in few minutes. For example, public transport company can invalidate SMS ticket when public transport company when inspector has already checked this ticket, or it can also use some sophisticated geographical correlation. I will explain it later. There is a possibility of full man-in-the-middle attack between the inspector and passenger mobile phone. And one of the most dangerous things from hacker side is using a private point-to-point mobile network. So, for example, when you have only one mobile phone which still send original SMS SMS request and receive SMS responses from public transport company and distribute them to many clients. This is a single point of failure. So public transport company can reveal this mobile phone because the same mobile phone is still used and can blacklist this mobile phone. For this situation, I proposed peer-to-peer mobile network, and when peer-to-peer mobile network is used, there is no possibility of blacklisting some specific number. Okay, so imagine the following situation. Let's assume that your SMS ticket is associated with your mobile number. So your mobile number is hashed in that SMS ticket token. So public transport inspector knows that what is original SMS what is original number that sent given SMS request. So inspector can look for duplicate SMS tickets. Okay, so this situation when public transport inspector meets some people and all these people use the same ticket, which is quite suspicious. So in this situation, there is a quite easy workaround. Every user must send regenerate token request to central SMS hack server. That means that SMS hack server send official SMS request for a new SMS ticket. A new valid SMS ticket is obtained by central SMS hack server and distributed to all clients. So this hackers workaround. Okay. So sometimes regeneration of SMS ticket can be too slow. Imagine a situation that you have 10 people and 10 people in one bus have the same tickets. So even if one of these users just press button regenerate ticket, it's too late to distribute the new ticket to rest 9 people. So for this situation, I proposed passenger geographical collision detection. This can be quite difficult to implement, but it should work. Okay. So we need to know exact geographical location of every passenger from our hackers community. There are 2 ways how we can find it. The first way is to use GPS, but not every smartphone or every mobile phone has integrated GPS. So then we use BTS name signal level triangulation that is used, for example, by Google Maps. In this situation, you don't need any GPS system, but there is still possible to find your approximate geographical position. So if we want to implement passenger geographical collision detection, we need to send position of every passenger of our community periodically to central hack server. Central SMS hack server is responsible for evaluation, possible collision, and in case when he detects when the SMS hack server detects that 2 passengers enter or 3 passengers with the same ticket enter to the same bus, it invalidates one of these tickets. So all passengers from hackers community in one bus will have different unique ticket. Okay, so public transport company can use sophisticated geographical correlation system. It means that it's quite strange when when inspector checks one person in for example, one part of Amsterdam, and in another 10 minutes, another inspector checks the same ticket 20 kilometers far. So public transport company can decide to make some very complex geographical correlation system to prevent this attack. But of course, it doesn't work, because in this situation, every user just send a regenerate token request after he's checked by inspector, and then new valid SMS ticket is distributed to all clients in a few seconds. So that doesn't work. Okay, so let's assume that inspector knows number of original sender of SMS ticket. So as the inspector can make a call to SMS ticket sender. Yes, he can do it, but there is another hacker's workaround. We will have some voice over IP asterisk server with GSM card, so we can detect this call from inspector, and we can ring to all members of we can make a call to all members of community. So inspector will see official call from his number, and he can pick up the call and communicate, no problem. Okay. Inspector also can send a verification SMS to the SMS ticket sender. We are also able to receive this SMS ticket using GSM card in our asterisk server, and we can redistribute these SMS to all participants, all passengers. And of course, we can spoof sender for this SMS to be inspector 1. And of course, inspector can ask the user to make a call to his number, which is quite complicated, but there is also a hacker's workaround. User just runs some voice over IP client in his mobile phone that make voice over IP call through the central SMS hack server to the inspector's phone. So of course, inspector will see the same number that was used for SMS ticket request. So these all are examples of man-in-the-middle attacks that really work. Okay, so yes?
Doesn't that mean that you're paying for all the tickets and the calls?
Can you speak to the microphone, please?
Well, doesn't that mean that you're paying for all the tickets and the calls, and it's not really working, because every time a ticket is checked, they request a new ticket, and so you're paying for a new ticket, so that's not really working, is it?
Yeah, but these some specific situation. These situations are quite expensive, but I think that inspector has no right to make any call to anyone, to any passengers, and also you also can be forced by inspector to make a call to his number. I think these just hypothetical examples.
Yeah, I know, but I'm not only talking about the calling. I'm also talking about if a ticket is checked, and you say the people in the client would say, well, my ticket's checked, so get me a new one, or get other people a new one. That means that for every check, a new ticket is bought, and therefore the system isn't working. And plus, you're paying for the tickets instead of they are.
Yeah, okay, but in all existing system, when you are checked by public transport inspector, you can be checked by another public transport inspector in a few minutes. So you need to have valid SMS ticket and also this possibility that you need to send some regenerate token is quite hypothetical, you know. So your SMS ticket should be valid for whole way. I mean you can meet 3, 4, 5 inspector per one way, and you need to show them the same SMS ticket, you know.
Oh, makes sense.
Okay. Okay, so in original proposal, we used one mobile phone which is connected to central SMS X server. This is quite bad because public transport company can reveal that all SMS requests are sent just from one number, one mobile phone, so they can very easily to blacklist this number and reject all SMS requests. So there are many choices how to solve this situation. The first one, we need to change SIM card, mobile number periodically. For example, in Czech Republic, it is completely it's possible to buy your mobile SIM card completely anonymously. I don't know what is the situation in Holland. Okay. Also, it is possible to buy.
You can buy. I don't know if it's possible, but I know that phone companies can see where your mobile is located. So you can put in new SIM cards every day.
Yeah.
If this is still next to the server, and the server is always in the same place, they will always see that it's from that one house where millions of tickets are.
Yeah, and it's because your mobile phone uses a serial number called IMEI, which is unique serial number.
That's not what I mean. I mean, in Holland,
Yeah.
I can get a special account where I pay less if I call from my home.
Yeah.
From my home.
Yeah.
Using my mobile phone. So apparently they know where I am.
Yeah.
And they also know that because if I dial the emergency number, they know where I am.
Yeah.
So they don't care which number it is or if it's anonymously.
Yeah.
They know from what place I'm calling anyway.
Yeah.
So they know all these requests, these SMS requests, have their origin in the same spot.
Yeah.
And if I change SIMs, it doesn't matter because they all originate from the same spot. So if I buy 1 million tickets over 1 month period from just one place geographically, it will raise suspicion as well.
Okay, but
so I move around with the server all the time.
But when you buy new SIM card, you will have new mobile number, and you can also change your email in your mobile phone. So I think there is no way from GSM company point of view how to detect that this mobile phone with the new email and new SIM card is yours. You know what I mean. Yeah. I'm talking. By the way, I'm talking about GSM. I'm talking about GSM and 3G. Okay, not PSTN. These. Okay, so.
I think that the public transport company is not allowed to get your location to check from which location is this SMS coming, even though the mobile operator will know it. I mean, that's my privacy. I can send an SMS, and they cannot check that.
Yeah, of course, you're right. Public transport company is not allowed to know your geographical position, but unfortunately, this is the only way how to detect this attack. Okay, but you are right. Okay, so you can use multiple SIM cards and mobile numbers in the central SMS server. So you can balance your SMS request to public transport company through a lot of mobile phones, or you can use pretty secure private point-to-point mobile networks. Okay, so is it possible to spoof SMS sender or caller ID? In case of SMS, yes, it's possible. You can check this service, phonytext.com, and using this service, you can send completely spoofed SMS ticket, and it works also in whole European Union, including Germany or Holland. And if you are voice over IP provider or you have access to channel SS7, you can also set your own caller ID, which is much more complicated. Okay, so I would like to explain how private peer-to-peer mobile network works. So, in original proposal, there is a single point of detection, and it's one mobile phone which is connected to the central SMS server. In private peer-to-peer mobile network, every member, every passenger will have own SMS sending server. So when the central SMS server receives that somebody is asking for a new SMS ticket, he will choose one of the members and tell him, now you will send your SMS your SMS request to public transport company. In a few seconds, he will receive response from public transport company, send back SMS response to the SMS server, and this SMS server distributes this valid SMS ticket to all members of community. It means that every time SMS request is sent from different number from different number, but this number is still inside of community. So if the community is enough large, for example, 100 people, you use 100 mobile phones for sending this SMS ticket. So, as I said, there is no single point of detection. Every client participates in sending SMS ticket request. Okay, so we can use email. Email is a unique identifier, which is something like serial number or MAC address of your mobile phone, and it's quite unique. In some countries, for example Latvia, it's illegal to change it. Email can be easily checked by inspector. You need to use this combination, and this works on every phone. So the solution how to make SMS ticket secure is that we need to bind passenger's email, or passenger email from his mobile phone with his SMS ticket. But of course, when we have email, we can do the passenger geographical localization. Okay? Geographical localization of Czech passenger is probably the only way how we can detect this attack. But as that guy said, public transport company is not allowed to know this kind of information. So we need to know a simple response for a question: is it just Czech passenger sufficiently close in a defined distance to the inspector? So we need to find a way how to solve this question. When we want to do geographical localization of passenger, we need to cooperate with GSM operator, because we need to know the exact name of BTS that the passenger and inspector is associated with. Okay? And also, all mobile operators have to join together and prepare some specific binary function called email proximity that returns true if mobile phone of public transport inspector is sufficiently close to the passenger. So if you want to prevent misuse, only a subset of some specific mobile phone, inspector mobile phone number can be used as email DVA. The problem is that this solution is very expensive and very difficult, because all GSM operators in one country should cooperate together. So it's really complicated. And the other thing, and which is quite handy and time consuming, is that inspector needs to type email of every Czech passenger, which is really complicated. But yeah, it can be it can be done, for example, some OCR or something like that. So this geographical localization is very expensive and very difficult. Okay, so I proposed a security fix that works. It is really necessary to associate the user identity with his SMS ticket. This can be done very easily. If if the user wants to use SMS ticket service, he just sent one registration SMS using register, his personal ID, for example, ID of his driving license, ID of his passport, ID of any documents he can show to the public transport inspector. I know this quite sensitive information, and personally I don't like this solution, but unfortunately this is the only solution that really works. So, public transport company just computes hashes of this user ID and associates it with his phone number. So public transport company will have only hashes of such sensitive information like IDs of driving license or IDs of passports. Of course, we need to be aware of rainbow table attacks. Okay, there are some solution. Okay, I propose two ways how to safely generate SMS ticket. The first one is using symmetric encryption. The second one is using asymmetric encryption, which is much more complicated. I'm going to talk something about symmetric encryption. This is very secure and a very easy usable solution. It means that the same key is used in central SMS ticket server, and the same key is distributed to all inspectors' PDAs. So when you meet inspector, the situation is quite easy. You need just show him your passport, your ID, your driving license, or anything. He just scan your ID document, and immediately he can know if there is any SMS ticket that was bought by this ID or not. So in this situation, you even don't need SMS ticket, which is really fun. So you can ask for SMS ticket home. You can leave your mobile phone home and just take your ID and show to inspector, and he scans your ID, and he immediately knows if you have valid tickets or not. So this, okay, so this quite specific implementation, very complex, complicated, very few processes using asymmetric encryption. Okay. These slides are available, so you can download it. Okay. The question is, does this fix look complicated? Not really. My proposed solution is even more user-friendly than the current solution, because in current solution, when you meet public transport inspector, you need to show him your unique SMS ticket. The inspector needs to put your unique SMS token to his PDA and verify if your SMS unique token is valid or not. So this current solution is not secure, and also is very time-consuming and handy. So my solution is secure and quite easy, because inspector just scans your personal ID document and visually compares the result of his PDA with your SMS ticket. And if he has the same unique string, everything is fine. Okay. The problem is that every inspector PDA should support automatic personal ID scanning and OCR or something like that. Okay. I think that's all. Okay. We have a few minutes more, so I'm ready for a question. Thank you a lot.
Got any questions? Oh, a lot.
Has anything like this been done?
Excuse me, can you speak more loudly?
Has something like this been done yet, like with people sharing the tickets?
You mean our own implementation?
Mm-hmm.
No. Oh, okay. We did some proof of concept, but the problem is that Prague Public Transport Company decided to sue me. So I decided I needed to promise them that I'm not going to continue in my own implementation. So.
And no one else has.
No. So, but I can. This quite technical. I can show you. In this presentation, there is also mentioned some technical stuff, how it works, the protocol, and so on. So you can write your own implementation.
Yeah, I want to ask you, do you know why in Holland they didn't decide to use this technology, and why we have a OV chip card, and why we don't use SMS servers? Is this because of this lack of security, or is there another reason that you know of that we don't have a SMS ticket service in Holland?
Personally, I don't know what is the current situation in Holland. But if you want to, I don't know. I don't know why these SMS tickets are not implemented here or not massively used. But in Central Europe, it's quite often, or it's very very favorite service, and a lot of people use it. So, for example, in Bratislava, for about 6 months, Bratislava Public Transport Company earned about 1 million euros just for SMS tickets. So it's a quite big business.
I got a question of my own. How do you handle validity periods? The SMS ticket you showed in the beginning, it had something like start period for 13:30 and stop at 14:20 or something. Wouldn't the inspector look a bit surprised if he's getting a freshly regenerated ticket with a validity period just a minute or so before he checked the ticket?
Okay. Can you say
when a ticket has been checked,
yeah,
and it is invalidated, you regenerate a new one, correct?
No, because when you are checked by inspector, you can meet another inspector in a few minutes, of course. So your ticket has to be valid for another 20, 30, I don't know how long is this. In my presentation, I just described pure hypothetical situation when public transport company decides to invalidate every checked SMS ticket, but practically your SMS ticket should be valid after every check. You know.
I see. And wouldn't it be much easier just having a pool of, say, 20 day tickets and handing them out randomly?
It's hard to say.
Okay. Anyone else?
It's just a clarification. I think I did not really understand. Who is paying for the ticket then? When you present the central server, and especially with the regeneration, you need to pay at some point for the ticket. So
yeah, of course. You pay just for one ticket, and when this ticket is shared by 100 people, 100 people share cost, of course. So, for example, in peak hours, from at 9 a.m., you just one passenger ask for valid SMS ticket, and another 100 people who are also from the same community share this ticket. So 100 people or all people from the community share expensive for one ticket, you know.
So the community has to share the price at some point?
So if the community is bigger, then your traveling is more cheaper, of course. But of course, if your community is bigger, that's also much more easily to reveal such community, of course. So you share your cost.
And also, don't you think it's dangerous to rely on the community to press this revalidate button after a check? That you have a community of people, they don't know each other, but you have to rely on other people to behave the way you say for the system to work.
Yeah, you need to have community of trusted people. It is really important. So if you accept some unknown people or some untrusted people, this really won't work. So you need to have community of trusted people. It's really important. And of course, if you have 100 people, it's quite difficult to provide or to that all these 100 people are trusted. So this works only in trusted communities.
Thank you.
I have one remark regarding the last thing about the community. If you all need to pay together for these few tickets you buy, it means there's some listing somewhere where you really have to pay. So there's on record some money going from me to one way or the other to the server where these tickets are bought. That would, I think, under Dutch law at least, make me part of a criminal organization, because the intent of the organization is to fraud tickets. And being part of a criminal organization is not a good thing. And I think the risk you run, in criminal law terms, isn't outweighed by the few euros you maybe win. How do you think about that?
Yes, of course. Such community is purely illegal, so it's a criminal activity, of course. But as I said, at this moment, it's not possible to detect it. So,
But also not looking at the cash flows needed to make this work.
Yeah.
Okay. But you need.
Yeah.
In this. So that's in the situation without the central server then. I think the central server thing is very scary.
No. But for example, it's when you decide to build such a hacker system, you can host your hacker SMS servers, for example, in Argentina or outside of Europe, of course, because when you use private peer-to-peer network, there is no need to have this server in your country, of course.
Okay.
So you can have this country, I don't know, in Philippines or something outside, and it works.
I have to shout anyway because otherwise you won't hear. You said it was easy to fake the caller ID using SS7. Is that really that easy?
Yes. When you have connection to channel SS7 call center, you can set your own caller ID, which is quite illegal, but it should work.
And that is not verified by the operator to which you are connected?
What?
Is that not verified by the operator to which you are connected through SS7?
Yes, it depends on operator. Some operators can refuse such spoofed caller ID, but some operators simply accept it. This is from my personal experience. And regarding text SMS messages, you can completely spoof your sender, and it works in whole European Union using phonetext.com.
Just a short note, if you have a large account service with a large SMS provider where you hand in SMS via TCP IP, or you have an SS7 trunk, there's no checking being done usually. So you are free to do whatever you want with the sender text. You do not even have to send a mobile number. You could even send an alphanumeric free text. Yeah, and for SS7 it's basically the same. There was one, I think, at Camp 2007 where SS7 was quite nicely explained. You could check it on the video archives.
By the way, for common people, it's quite complicated to gain access to channel SS7 call center, but you can hack it, of course, if you are a criminal.
Another note, SS7 providers or trunks can be easily bought from voice over IP providers if you request a large enough number of dial-through extensions.
Yes.
Right. Anything else? Any further questions? Okay, in that case, thank you very much for your talk.
Okay. Thank you.